So I'm going to talk about Quart, which is a side project of mine, which combines Flask with Asyncio. And I'm going to try and explain some of the difficulties that come about when you try and do this and why you'd want to do it. So I suspect most of you here are probably quite familiar with Django, so I thought I'd give a bit of an introduction to Flask. I hope there are some Flask people here though. But Flask, like Django, is a whiskey framework. Unlike Django, it's a micro framework. So it doesn't have anywhere near the amount of features that Django does. But this is typically provided in the quite rich extension ecosystem. And what I got up here, just as a kind of introduction, is the kind of shortest, quick example of how to get a very minimal thing going in Flask. So this is very simply a web server that returns the index HTML page on the root path. And that's pretty much it. You can actually go and run this and then send traffic to it. So that's Flask. You don't want to just run it like that though, because Flask in itself is synchronous, and it can only handle the one request at a time. And this is unlikely to be sufficient for any kind of production need you have. So instead what you want to do is add some kind of asynchronous framework for when you're serving it. And for me, I'm familiar with Unicorn, and I use something like eventual to do this. And whilst these numbers are just representative, I just pick them out, it really is the case that you can handle a couple of orders of magnitude more concurrent requests with an asynchronous framework than you can just with a synchronous one. So this is kind of what you need to do to get Flask running in production. So I thought I'd keep motivating this, I'd quickly say what a async framework gives you, what a async event loop gives you. And if you imagine that you have two tasks, and we could say that each of these tasks is a request, in a sync framework you'd have to finish the first task before you could go on and start the second and then finish the second. And if you have some I/O, which you almost certainly do with a web framework, just the framework itself is I/O, then whilst that I/O is blocking your execution, your whole application is blocked. So what an event loop gives you, or what an async framework gives you, is this concurrency. So if you imagine we have these two tasks, and on the first iteration of the event loop, we start task one, and at some time, by this small open box, it does an I/O operation. Whilst task one is now waiting for that I/O, we can yield control back to the event loop. And the event loop can iterate through the tasks and find out actually there's a task it can run, which is task 2. And so it runs task 2. And let's say during task 2, the I/O operation completes. So then by the time task 2 is completed and control's been given back to the event loop, when it iterates again, the event loop can run task 1 until it finishes. So we've kept the CPU occupied and we've handled tasks concurrently, and we've got an improvement there. And like I say, web frameworks or web servers are typically very heavy on the I/O for all the stuff they do. So this is quite an advantage. So hopefully I've given you an idea why I quite like Flask, or I just like Flask, and I want to use it in production with some kind of async framework. It turns out there's quite a lot of choice, as this comic I think makes light of. For those of you who've been around Python for some time, there's stuff like Twisted, Tornado, Eventlet, Events. I'm sure there's more. Those are the ones I can think of right now. And I think Asyncio was supposed to be the one to kind of rule them all, if you will. And of course, it's blessed in the standard library, so it probably is going to rule them all. Although it has in itself inspired 2 new extra ones, possibly more, such as Curio and Trio, if you've heard of those. But Asyncio is in the standard library, so it should win. So I was trying to figure what the simplest kind of introduction to Asyncio I could come up with. And I think it's this one here. So for those of you who are not familiar, if you want to use Asyncio, it's effectively the combination of the async and await keywords and an event loop to run stuff. So in this little example here, I have a synchronous function called coroutine in the parlance that prints a message after it's slept for some time. And that await of the sleep means that this coroutine will yield control back to the event loop. So if I run 2 tasks in this event loop, hello world and world hello, I might think from my synchronous experience that it will print hello world first and then world hello. But of course, because it yields control back to the event loop, and the world hello one is shorter, then it's going to print out the other way around. So this is probably the easiest example I could show. There's one other quite key difference, I think, to Async and many of the previous frameworks that existed, in that it's very explicit. You see these async and await keywords. Stuff like event network events, if you're familiar at all with them, are implicit, so you don't actually necessarily know when they're going to yield control back. With Async, you know, and you have to write it down. Okay, so I know about Flask, I know about Async, and what I want to do is combine the two. So ideally, I want to go from what's on the right and end up with what's on the left. And the main difference here is in the hello world view function, it's a coroutine, it's asynchronous, and it awaits the render template, because that's going to be I/O when it loads that file. And I've renamed it Quart, and I'll come into why I've had to rename it in the following slides. But that's it, basically, and I'll try and show what this allows in a couple of slides. So the kind of first issue I think you face with asynchronous coding, people have called the color problem, if you will. And I think this is easy to explain. If you try and trigger synchronous code from a synchronous function, that's quite easy. You can call bath and foo, it works, you're very happy. Equally, you can trigger asynchronous code or coroutine from a coroutine, you can await it. And you can trigger synchronous code from a coroutine, you just call it. That's all very easy. When it becomes difficult is when you try and trigger a coroutine from a synchronous function, because the coroutine can't run itself, it needs to have the event loop run it. And in both of these examples here, if I just call it directly or I try and await it, there's no way for me to give control back to the event loop. So the first one just creates a coroutine object, and the second one is a syntax error. It'll actually not run at all. So this is problematic, but it gets worse, because it's viral. So if you imagine that example I started off with, I want the view function to be async. So I want to add async in front of the def. To do that, of course, and to trigger that view function to work, I now need to await it when it's called. And in Flask, it's this dispatch request method. But to await it in that dispatch request method, that dispatch request method also has to be a coroutine. And you can imagine this is going to go all the way up the stack until I somehow introduce the event loop. And ideally, you want to introduce the event loop at the level where you're controlling the I/O, because inevitably, it's all about making use of the CPU when the I/O is blocking. So this is problematic, this viral difficulty. And this, I think, is what prevents you from just taking Flask and adding async and await everywhere and hoping for it to work, because it has no concept of this event loop level. Okay, so as a brief digression, this problem has inspired something called the Sans IO movement. And the idea here is that if you're writing a kind of protocol implementation, you should write the part without the I/O and let the user choose how they want to do the I/O. So to give you a quick example, if I take a really nice library that exists called HyperH2, which does HTTP2, I can create a connection object there. And then all I need to do is get data from the I/O, either by awaiting it or some synchronous command. I just get some data. I then can pass it to the connection, and that will interpret the data in the protocol and tell me what it represents. Maybe it's a request. And then I can tell that connection what I want to do. Maybe I send a response. And then that connection object is going to give me some data to send back out through the I/O. So, and again, I can do that synchronously or asynchronously. So this is a bit of a digression, but a kind of plea to write your protocol libraries in this way. Ignore the I/O, and then you don't have a color problem. That's up to the user. But going back to Flask and how to actually go about making it work with Async IO, the biggest problem I faced, and the one I want to talk about, is these Flask globals. And they're a bit controversial. I think most of the other frameworks don't go this route. I'm sure there's been a lot of internet discussion of it. But in Flask, there's this request global that no matter how many requests you're handling concurrently at that time, will always return the request you're handling. So if you imagine many routes, even if there's a request to all those routes, it's going to return information about the request you need to know. So we need to make this work. And I've used an F string here simply to remind myself to warn you that pretty much none of what I'm talking about will work in anything less than Python 3.6. So yeah, Python 2 is quite old anyway. So what is this request object? Well, in Flask, it's a local proxy, which looks a bit daunting, but the basic idea is that any action you try and take on the request object is proxied to a different object. So, for example, if I try and get an attribute, most of the actions will be like that, it will call this resolver function to find another object to run that action on. And as you can see from the lambda on the second line, all that resolver function does is gets the request attribute from this locals instance. Now, some of you familiar with thread locals in Python probably now know where this is going. And indeed, that local object is effectively a thread local. Basically, it has a dictionary of storage, which is going to be keyed by some identity function. And the identity function is basically the key. So that identity function has got to return information about that is local to the request you're handling. And to finish off the hints here, the way Flask makes this work is that each thread will handle a single request. And that's either a real thread or a green thread or task, if you're familiar with those terms. And so no matter which thread you're on, it's going to return the right information through this little mechanism. And for Flask, as I was saying, greenlet or green thread in the parlance has an identity, and so does thread. So that's how, whenever you try and get something on the request, it's going to resolve it to that thread local, and then it's going to find the one for that particular thread. So for Asyncio, I obviously need to mimic this in the same ideas for Asyncio. And the way this works is to think about, instead of threads, to think about tasks now. So if instead of having a request per thread, I have a request per task, then I can use an identity function much like this and use all the machinery that already exists. So whenever I try and do something on that global, it's going to resolve it to the request that's local to the task that's currently running. And that's the basic bit to make this work, really. That's all you need. So to put it all together, what I effectively need to do is when I receive data, I need to create a task to handle that request in. And for Async.io, you can turn a coroutine into a task by using the ensure future function. Futures and tasks are a little bit interchangeable, which can be a bit confusing, but this creates a task. So of course, in this coroutine, I can set the request in the locals and then call that dispatch request function that I talked about earlier, and I can await it. I've solved the color issue. So with all of this, I can actually go ahead and implement almost the whole of Flask's API using Async.io. And I'm not going to go through this because it's way too complicated probably to even be on the slide. But I want to motivate one of the big kind of gains from this is that you can use these modern libraries like Async PG, which are reported to be very, very fast. So Async PG is claimed to be much quicker than Psycho PG. I haven't actually tried it in production to know for sure, but the figures are very, very impressive. So clearly with Quart, I can just make this work. So that allows me to do the whole of Flask, but of course it's not enough. What really makes Flask ace is its very large ecosystem of extensions. I've just listed a few here, the more common ones or the ones I'm more familiar with. And I'm going to need Quart to be able to work with these. And the problem is that these extensions aren't going to know that Quart exists, and they're not going to care. So the first thing they're going to do is they're going to try and import stuff from Flask instead of Quart. That's problematic. And then the second thing they're going to do is that color problem. They're going to call coroutines instead of awaiting them. So I need to solve both of these. Now, Python makes it really easy to monkey patch everything. It's perhaps dangerous, but in this case, it's really helpful. So what I could do here is I can just go through all the modules that already exist, find the ones that are called Quart, copy that module, call it Flask, and then put it back in the modules list. So any extension after this is going to find a Flask module and import the Quart objects and just think they're the Flask objects. So I take care of the first problem. And because it's the same API, they should just work, up until this color problem. So, just to give you a reminder of this color problem, it's really about triggering and running this asynchronous code in a synchronous function. The first one's a syntax error. The second one is probably where you'd go when you get any familiarity with Async AO. I've hopefully given you enough hints that to run a coroutine, you need an event loop. So your initial thought would be, well, I'll grab an event loop and tell it to run it. And this works really well unless you're already inside the event loop. So if this function foo has been called from within a task, this is going to raise a runtime error, and it's going to fail. And what we really want is something like this last example of something on the event loop that allows us to run a coroutine within the event loop itself. And I've called it sync wait because that's actually what was proposed for Async AO at the time, but sadly rejected. And I think it was rejected because the only real time you want to do this is if you want to somehow combine like legacy synchronous code with new asynchronous code. And I suspect the assumption was that was probably a bad idea. But you can go ahead and do this anyway. So to do this, and I've not put the whole details here, but I want to kind of talk it through to give you a better idea of how these event loops work. It's in principle quite simple. When you enter this sync wait method, you just get and save the current state of the event loop. You keep it and you put it to the side. And then you run the event loop yourself. So you can see I'm iterating through the loop until my task is done or cancelled. And then when my task is done, I simply restore the loop to its previous state and return the result. So it is in principle that easy, and I invite you to take a look at the Quart code to see the actual details of how you save and restore that state. There are some caveats about it which can make it a bit complex and difficult to use in practice. But anyway, let's say it works. I can now monkey patch it onto the event loop, again, abusing the power of Python, and it works. So putting it all together, all I need to do now is when I monkey patch those Flask modules, I just need to have the one for templating return this render template function, which wraps the Quart one. So now any Flask extension trying to use render template has a synchronous version that's going to call the asynchronous Quart version, and everything, hopefully, is going to work. Although the stack traces are a bit messy. So I hope if I've explained it well, that seemed rather simple. I suspect I haven't explained it well, so please come and talk to me if you'd like to know more. So Quart exists now. It's been a bit of a learning project for me, and I'm at the stage now where I'm interested to know if it's of any use to anyone. It's available on GitLab at that address. It does pretty much everything Flask does. There's some details of the API I haven't replicated yet, but the most use cases should be there. Over time, it will just get, hopefully, complete. It's compatible with most extensions. Unfortunately, there are places where I can't monkey patch in that sync wait between the extension and the Quart code. So not quite all of them, but it's only a couple left now. I just need to figure of something more inventive for those. And because it inherently understands that there are multiple requests going on at the same time, it can really handle pipelining, which means it's very good for HTTP2 in a way that I don't think Flask will be able to do. So Quart does support HTTP2 out the box. And I guess the last bit I wanted to kind of give you as a motivating factor for this is it does look as if the Async AO framework and perhaps the HTTP parsers I'm using are quicker than those that are available for Flask. So especially UV loop, which is made by the same people as the Async PG one I mentioned earlier. There's very good suggestions that is very quick. I think I actually maybe rushed it a bit. So maybe there could be questions.
That was a great talk. Thank you very much, Phil. So, casting it out to the room to questions. Does anybody have a question? Yes, in the blue T-shirt.
So there's two questions, not related. I think I missed something. I don't really get why the synchronous asynchronous
All right, so to the first question regarding the color, I think it's just the way that it's talked about to make it a bit clearer. In this case, it seems to have made it less clear, sadly. But the idea is that you can, if the functions have a color, you can call black from black, but not red from black or something like that. So that's how it's supposed to make it clear. To your second question, I definitely think Flask is very good for production. My phrase about it being problematic was, if you run Flask alone without a whiskey server in front of it, then you get performance issues.
I see a question in a grey jumper there.
Yeah, so the question is, why use Asyncio rather than, say, Gunicorn and Eventlet? I think it's so for me, I think it's because I believe Asyncio will become the dominant async framework because it's in the standard library. Equally, I think it's quicker to use Asyncio than Eventlet. But finally, I want to be able to use some of these new libraries like Async PG, which are reported to be very quick. And I will only be able to use those if I'm using Asyncio, I think.
Tibbs?
Can't remember what Flask is. It's MIT. I think Flask is BSD, is it? I'd have to look up. I'm sorry. Oh, MIT.
I see a question in the front row.
What's the most interesting thing you learned about Flask while building Quart?
Oh, I think it was, so the most interesting thing I learned, I think, was how those local proxies worked. Because it was always a bit of a mystery to me how this one apparent global variable could refer to many different actual instances and pieces of data at the same time. So, yeah, that was one of the most interesting. Hopefully I've explained to you how it works as well.
I see another question there at the back. I'm talking to you.
Oh, so the point I was trying to make here with the await question mark was merely that the Hyper H2 library doesn't matter whether your I/O is synchronous or asynchronous. You can use await or you can choose not to use await. It's still going to work. And that's the key of the Sans I/O. You've separated the I/O from the protocol passing. Is that clear?
Yep. I saw a blue t-shirt just front here.
I'll put them up here, don't we?
Yeah, so just to be clear, all the slides and link videos that we have links for will be posted on the website soon. Over there at the back.
I'm going to say no, but I'd like people to try it and tell me issues.
Production ready, but just not for you.
Yes.
Any more questions? I saw one back there at the back, in purple.
I don't fully understand your question, sorry. Yeah, so I think your point is if running tasks concurrently and they somehow depend on each other, then I can have race conditions and surprise states. Yes, I think one of the advantages of a web framework for this, though, is that typically requests are fully independent and they're handled as such. Equally, I think it's one of the advantages of Async I/O that it makes it very explicit when this can happen. So you know when you will yield control back to the event loop. So you've got some clue as to where your issues between two different requests could take place.
I think I saw a question in the front. Yep, in the black t-shirt.
Oh, I think you're asking how much resources does it use compared with Gunicorn and Eventlet. I have no idea. I haven't looked. Sorry.
Okay.
Ooh, I don't know.
Okay, so Samanthy's hand go up.
How PyCon is more with Flask, so if Flask change their internal stuff, is that going to affect Quart? Is there going to be a delay between
It could be a problem, yeah, but Flask is working towards the 1.0 release at the moment, which I think, especially with the history of Flask, will be very stable. So I think they've basically got their API fixed. So whilst you're right, Quart does have to follow Flask to keep the same API, I don't think it's going to change much.
I think we've got time for one more question if anybody has one. I'm not seeing any hands go up, so I think we'll close it there. Thank you very much for that session. That was excellent. We now go directly into our break, and then in half an hour, so you can go and get some coffee and Welsh cakes, and in half an hour's time we'll be back in here for some more sessions.